Hello Year 12, this lesson is going to be looking at population momentum and population pyramids. Now, both these things are in our syllabus objectives, so it means that they can show up on the exam, and we've seen a lot of questions relating to them in previous external exams. So it seems like the exam creators like to use both these topics in the exam. So we're going to cover that today. On the QLearn, if you go to Unit 4, Topic 2, Global Population Change, and click on that one, wait for that to load. You'll see all our lessons here. Then down here where you see study lessons, you will see that there is a lesson on population pyramids and momentum. So click on that one. There are some get ready activities for you to complete. There's 4 flashcards that you should have about population pyramids and one on population momentum. I would like you to test yourself using those. Maybe you can find a friend or a family member to help you with it and try and recite the answers that are on the back of these cards. If you've lost your flashcards, you can find the document with all the flashcards under the helpful resources section of your QLearn on the home page. There should be a link there to download the Word document. Today we're going to go over this PowerPoint here, understanding population pyramids and momentum. So I'm just going to download that one. There we go. Let me just put it into slideshow view. There we go. So understanding population and pyramids and momentum. So we're going to dive deep into population structures and their implications. So the basics of a population pyramid that you need to know. So looking on the right hand side here at the diagram here of a population pyramid, we can see that the height of the pyramid indicates life expectancy. So we can see between the ages of 0 and 100 here. Then with the columns coming off of the vertical axis here, we can see the proportion of the population that lies within each of those ages. On this one, the horizontal axis shows just the population in millions. Other population pyramids may show in percentage, so it tends to differ. So always have a look at the labeling on that x-axis. We have the males on the left-hand side and females on the right-hand side. Then what we can see, if it's showing proportion of population, the width of the pyramid indicates the structure of the population. So why is it important to actually look at population structure in demography and look at these pyramids? So one reason is socio-economic planning. So understanding the age distribution helps governments and policymakers make informed decisions about resource allocation, such as schools, healthcare, and retirement services. Now, this does not have to be on a national scale. It doesn't have to be just for an entire country. It can be looking at a state level, and it can even be looking at a level, just looking at local district levels. So just like a suburb. So for instance, Pimpama has a very young population. What does that tell government policymakers when they look at the population pyramid? Well, Pimpama likely needs more schools. If we look at areas such as the Northern Rivers, the Tweed area, they'll see that there is a very old population. What does that tell policymakers? Well, it tells them that they need more healthcare facilities and retirement services. So that's one of the reasons we look at population pyramids and structure. Another reason is economic growth potential. A large working age population can be an asset for economic growth, while a very elderly or very young population might pose economic challenges. That is our dependency ratios. So how many dependents and independents we have. And last, public health. So different age structures can point to different health needs. So instance, a younger population might need more maternal and child health services, while an older population would need more chronic disease care and geriatric services. So looking at our pyramids, the first pyramid we can see is our expansive pyramid. This is one where it just looks like a typical pyramid. It's the one we see a lot throughout the world for our most developing nations. How can we tell a nation is developing So meaning they're not developed, they're like a third world country based on this pyramid here. So the reason we can tell this is we can tell that it has high birth rates because when we look at the age cohorts between 0 and 4, 5 to 9, 10 to 14, this younger age, our dependents, our younger age population, it makes up the largest population, right? When we compare it to our middle and older ages. So what that tells us is that they have quite a high birth rate. However, we can see that the population tends to narrow in quite fast. That tells us that they have high death rates. The people who are born and they're between the ages 0 and 4 are likely not all going to live to these middle ages. So we also have high death rates. We can see they have a young population because a significant portion of the people are under the age of 15. And it also means that they likely have a short life expectancy due to this steep decline. So we can observe these in less developed countries or regions where access to healthcare may be limited, education levels, especially for women, might be lower, and there might be cultural or economic incentives for larger families. So this pyramid is for Nigeria's population in 2016. And we see this type of pyramid for a lot of African nations and a few Asian nations as well. This is our expansive pyramid. So this would tell policymakers a lot about this country. It would tell them about the challenges being healthcare and most likely education. But it would also tell us that if we were to help with the healthcare situation, that we're likely going to have a big boom in the increase of our population as well. Because these ages would start living longer as our population increases. We move to our stationary pyramid now. So our stationary pyramid we can see looks more like a column. Now, though we describe it like a column, it's not going to look exactly like one. We're not going to have it where our age group between 0 and 4, we can see it goes up to 10 million, is going to be the exact same all the way up to 100 plus. We're not going to have people all the way living to 100 of the same population there as we have in our middle and lower age cohorts. Because eventually our population has to start dying off. We call it a column because from our younger age to middle age to our start of our elderly age group, it's like a column. It's roughly the same population. It then eventually starts to narrow in at the very old age cohorts because eventually it has to. But it's more like a column. What does this tell us? It tells us that there is low birth rates. The base of the pyramid is not particularly wide, and we can see that there's not like any wide areas when we're comparing it to other cohorts. This is often due to factors such as increased access to education and family planning, urbanization, and a cultural shift towards smaller family sizes. We have low death rates, so the pyramid remains relatively uniform in width from base to top, suggesting that a higher proportion of individuals survive to older age compared to more expansive pyramids. And we have an aging population. Aging population does not mean our population is already old. It just means that year on year our population is becoming older as these as this group here moves up these age brackets. So our population on average gets older. Because both birth and death rates are low, the population is often older on average, with a significant proportion of individuals in the middle and upper age cohorts. And we have minimal population growth. Since the birth rate is roughly equal to the death rate, there's little to no natural increase in the population. So these pyramids are often associated with more developed countries or regions where there's good access to healthcare, education, and employment, leading to both lower fertility and increased life expectancy. And we have our final population pyramid. This is our constrictive pyramid. With our constrictive pyramid, we can see there's low birth rates. Look at the pyramid here. The largest cohorts for Germany's population in 2016 are between the ages of 45 and 60. And we can see that some of our smaller cohorts are very, very young populations here. There are young dependents. So that means there are low birth rates. So we see the narrowed or pinched base indicating fewer children are being born, reflecting lower fertility rates. We can see it is an aging population or potentially already aged. So given a larger proportion of middle-aged and elderly individuals in the population, the median age tends to be higher. And we can definitely see that on this one. Especially as we can see people between the age of 45 and 60 in the next decade or two would all be in these upper age brackets. Increased longevity, the wider top part of the pyramid indicates that a higher proportion of the population is living to an older age due to factors such as better healthcare, nutrition, and quality of life. So we can tell that these type of pyramids would belong to much more developed nations, so our more economically developed countries, our first world countries. We can see potential economic challenges. So over time, as a larger, older population retires, there might be fewer working age people to support the elderly, which can pose economic and social challenges. And we have possible pension and healthcare strains. With an aging population, there's often an increased demand for healthcare services and pension benefits. So countries or regions with constrictive population pyramids are typically more developed with higher levels of education, better access to healthcare, and widespread use of family planning. The examples are Japan, Germany, and Italy. So there are three population pyramids. You need to know those three. Now moving on to population momentum. Now this is a concept that a lot of people find tricky to understand. So with population momentum, typically we would look at a population pyramid like we are now with India, and we would normally look at a fertility rate. If we remember with fertility rate, it's the amount of children on average that are born to a woman, to one woman. We need 2.1 on average for fertility rate to naturally replace our population. Okay? So 2.1, the reason for that, it's two people being born, because that would counteract a mother and father dying. And then 0.1, because not all children will live until their reproductive ages. So 2.1 on average. For less developed countries, it might need to be higher because more younger people die before they reach those older ages. So looking at population momentum. Population growth has a lot to do with the age structure of the population. The higher the percentage of young people, especially those under age 15, the more the population will continue to rise as this large cohort, this segment of the population, enters their reproductive years, so 15 to 49. Once this young group moves beyond childbearing age, the momentum will decrease and population can begin to stabilize. So basically, let's look at India here. We can see India's population is quite, looks like more like an expansive pyramid. We have lots of people in their younger ages here. So what that tells us is that the next cohorts that are yet to be born are likely also going to be quite large. But let's say, for instance, India's fertility rate drops. Let's say it drops to 1.3, well below replacement rate. Well, does that mean that India's population is going to decline? No. And the reason is all to do with the age structure of the pyramid. Okay, so their new cohort then is going to be a lot smaller than this current cohort, the current cohorts we see. Let's say the new one goes up to 39 million, for instance, because of the big drop in um, in our fertility rate. Or even let's say it goes to 26. It's still going to increase the population. Why is that? Because it's still a larger cohort being born than the amount of older people who are likely to die. Because we can see that these older age brackets are less than 13 million, many of them. These are the people who are likely to pass away. And so, even though we have our replacement rate, so our fertility rate is going to be so low, our population still expands in that short to medium term. And we call this a lag. Only when our reproductive ages, our largest cohort, gets to this old age where they post-reproductive years, where they can't have any more children, do we then see our population start to decrease. So that is what we call population momentum. We also have one called negative population momentum. It's the exact opposite. Let's look at Japan here. With Japan, we can see that the younger age brackets are some of the smallest cohorts. So that means that it's likely their fertility rate is already below replacement level. It's already below 2.1. For Japan, it is currently. So that means their population is decreasing. And we can see with Japan, they have a very old population. Look how many people are in these age cohorts between 65 and 80. There's a lot of people. There's even just about the same amount of people who are 80 to 84 than there are of people who are 0 to 4. So we can see a very old population. Well, let's say Japan all of a sudden decides or somehow moves to a fertility rate that's above replacement rate. Does that mean their population increases? Well, it should, but it doesn't in this case because of their structure. Because they have so many old people, and they don't have as many people in the reproductive ages, even if they were to increase their fertility rate, their population wouldn't increase because there would be more people dying because it's so old, this population, than people being born. And so their population still decreases in the short to medium term until eventually we see these older people die off, these younger people who are yet to be born go into reproductive age, and then would we see our population increasing. So momentum is all about a lag in the system. So that is negative population momentum. Now, I would like you to go back to the QLearn. You will see on the Give Me More here, there is a population momentum question I would like you to answer. Thank you for watching.